in the previous class we have seen about the recurrence relation, mathematical induction and so on. So in this class we are going to see about principle of inclusion and exclusion. So what do you mean by the principle of inclusion and exclusion? So it is given by the formula. If you have two sets A and B, so cardinality of A union B is given by, already you have find this formula in your set language, is it not? So cardinality of A union B is given by cardinality of A plus B minus A intersection B. If you have three sets A, B and C, so the cardinality is given by A union B union C is equal to cardinality of A plus B plus C. That is, individually you have to write the set and pairwise you have to combine, that is cardinality of A intersection B, A intersection C and B intersection C, and finally the all the sets A intersection B intersection C you have to write. So this is the formula for two sets and this is the formula for two sets. Now let us come to the problem. So what is given? In a survey of 100 students, it was found that 30 studied mathematics, 54 studied statistics and 25 studied OR and 1 studied all the 3 subjects. So totally we are having 3 subjects: mathematics, statistics and operations research. So here 100 students are studying those 3 subjects and 30 students studied mathematics, 54 studied statistics and 25 studied OR. And only 1 student studied all the 3 subjects and 20 students studied mathematics and statistics and 3 studied mathematics and OR and 15 studied statistics and OR. So here our question is, how many students studied none of the subjects? So for finding the students studying none of the subjects, you have to first calculate the students those who have studied all the subjects. So how will you find the students studied all the subjects? So that is given by the formula this one. That is cardinality of A union B union C is given by the students studied all the 3 subjects. So after calculating this cardinality, you have to subtract this from the total number of students. So total number of students is given by 100. You have to subtract 100 minus this value, cardinality of A union B union C. Okay, let me write this in our mathematical notation. So first let us write the number of students studying mathematics. So let me express this in the notation. Let A denote the number of students studying mathematics and B denote the number of students studying statistics and C denote the number of students studying operations research. So what is given? Cardinality of A, that is math study students is given by only 30 students. So cardinality of A is 30. Similarly statistics students, that is cardinality of B is given by 54. And OR students, that is cardinality of C is given by 25. One study all the 3 subjects. So all the 3 subjects means A intersection B intersection C is given by 1. 20 studies maths and statistics. So maths and statistics means A intersection B. So A intersection B is 20. Next 3 study maths and OR. Maths and OR means A intersection C. So A intersection C is equal to 3. 15 study stat and OR. So stat and OR is B intersection C. So B intersection C is equal to 15. So all the data are available. So this is our formula. So let us substitute this. So which is equal to, so this is nothing but number of students study all the subjects. So equal to cardinality of A, that is 30 plus B is 54 plus C is 25 minus A intersection B. A intersection B is 20 minus B intersection C. B intersection C is 15 minus A intersection C is 3 plus 1. So when you add this, what you get? 30, 84, 25. So this is the answer is 72. Cardinality of A union B union C is 72. So therefore none of the subjects. So none of the subject is given by, you have to subtract total minus this cardinality of A union B union C. So which is equal to, total is 100. So 100 minus 72, that is 28 students. So 28 students study none of the subjects. And the second sum you can take as homework. When you draw the Venn diagram itself, you can easily calculate only the mathematics study student. Hope you understand. Thank you.